We've learned that one of the properties of gases is that each gas molecule is independent of one another. That means they do not depend on one another because we neglect the molecular interaction between gas molecules. And so, if you look at this diagram here between two gases for oxygen and nitrogen, each for one container that has only oxygen, it has a pressure of 159 millimeters mercury. For nitrogen alone, it has a pressure of around 593 millimeters mercury. Now, because each gas is independent of one another, that means if you mix two gases for oxygen and nitrogen in one container of the same volume and temperature, you would notice that the pressure, total pressure of the mixture of gases is just the summation of the individual gas pressure of oxygen and nitrogen, such that if you add 159 millimeters mercury and 593 millimeters mercury, you would get 752 millimeters mercury as the total. Similarly, you can also safely assume that since we sum up the pressure, you can also sum up the total amount of gases, usually in terms of moles, in one container when you get one mixture of different gases. So this is so much related to Dalton's law of partial pressure, which is simply put, the total pressure of a gas mixture in an isolated container is just equal to the sum of the individual pressure of each gas. Say, for example, you have gas A, gas B, gas C. You can just add the individual pressure. Now, when you are adding, take note that the unit of individual pressure has to be the same so that you can add and get the correct total pressure. And also, because this is very simple, because I also said that you can safely just add also the amount of individual gas component in a mixture of gases, we can also relate the partial pressure or the total pressure to mole fraction. Now, what is mole fraction? Mole fraction simply symbolizes X, big letter X, is just the ratio because it's a fraction. It's the ratio of the mole of one substance divided by total moles. Such that if you're getting the mole fraction of a substance A and add it to substance B's mole fraction and then mole fraction of substance C and so on and so forth, because this is a fraction of one mixture and this is a fraction, so it's less than 1. When you add the mole fraction of the individual component of a mixture, you'll always get a 1, which is a whole number because it's a fraction. So all the mole fraction of all the components of a mixture will always sum up to 1. That is like the same concept with Dalton's law of partial pressure, that the total pressure of a mixture of gases is just equal to the sum of the individual pressures of each gas. So combining the concept of mole fraction and partial pressure, in which you have two options to get the partial pressure of a gas. Either you can use the ideal gas law, so A means gas A, whatever that is. So the partial pressure of gas A can be equal to the mole amount of gas A times RT over V, which is that. Or if the mole fraction is given for gas A, you can just safely calculate for the partial pressure of A by multiplying the mole fraction of A times the total pressure. So investigate in your problem later on about Dalton's law what variables you're given. You can use ideal gas law if you're given temperature and volume, and you can get the mole of A. But if you're not given T and V, but instead you're given the mole fraction of A and the total pressure of the gas, then you can use this particular expression of mole fraction. So you have two options to get the partial pressure of a certain gas component. So in summary for Dalton's law is again the total pressure of the gas mixture is equal to the sum of the individual pressures of each gas component in one mixture, or to get also the partial pressure of each gas, you can just use total pressure times the mole fraction of that gas. And how to get mole fraction again? The mole fraction is just equal to the ratio of the mole of that gas divided by the total moles of all the components in the mixture. So small letter n is always about the mole. Take note of these three basic expressions for Dalton's law and watch for the next series of this video for the computation of Dalton's law applying all these equations. So please take note of this and remember that the concept of Dalton's law is put simply, total pressure is equal to the sum of individual pressures of each gas component, which is similar to mole fraction, which is mole fraction is the individual mole fraction of all the components in a mixture, and combining mole fraction with total pressure to get partial pressure, it's just the mole fraction of that component times the total pressure. And mole fractions expression is always the fraction of that component in moles divided by the total moles. So again, watch for the next video about how to apply these equations in a problem solving. So this has been Madam Narka saying don't stop learning, relearning, and unlearning. Do like, share, and subscribe to my channel. God bless you all. Bye for now. Bye.